Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for progression, CP, GP and HP. In the previous session we have discussed some problems. In this session we are going to take some more problems, some higher level problems in fact, based on AP, GP and HP. So just get ready with your paper and pen and start solving the problems right with me. Okay? Now we see this problem. If A, B, C are positive real numbers, then A by B plus B by C plus C by A is greater than or equal to. It's going to be an important concept. Questions based on the properties of arithmetic mean, geometric mean and harmonic mean are frequently asked in competitive exams. So just listen to me carefully. We have already discussed the property of AM, GM and HM, that AM is greater than equal to GM is greater than equal to HM. Arithmetic mean of positive numbers and positive numbers is always greater than equal to their geometric mean, which is always greater than their harmonic mean, right? All of them will be equal if the numbers are same, right? But the numbers have to be positive, right? If we are talking about, suppose ABC, positive real numbers, right? So ABC, if they are positive real numbers, then their arithmetic mean will be greater than their geometric mean, and that will be greater than their harmonic mean, right? Now we have to find out the maximum value of this, right? That means the minimum value. It's this expression is greater than or equal to. That means what? Value of this expression will not be less than, right? Or we can say minimum value of this expression we have to find out, right? So precisely A by B plus B by C plus C by A. A, B, C have been given to us as positive real numbers. So A by B is also positive, B by C is also positive and C by A is also positive, right? So what I do is I take these three different numbers, A by B, B by C and C by A. So what will be their arithmetic mean? A by B plus B by C plus C by A by 3. So this is the arithmetic mean of A by B, B by C and C by A. Okay, and arithmetic mean of these three will always be greater than their geometric mean. Okay, so that's greater than equal to their geometric mean. Geometric mean is what? Cube root of these three numbers, A by B, B by C and C by A. Okay, so precisely A by B plus B by C plus C by A by 3 is greater than equal to cube root of 1. So precisely this is 1. So A by B plus B by C plus C by A is greater than equal to 3. Okay, so the minimum value of this expression, right? It's always greater than equal to 3. If A, B, C are unequal, then A by B plus B by C plus C by A will be greater than 3, right? So minimum value of this expression is 3. That means this expression is always more than 3. Okay, it will be 3 only in one case, when A is equal to B is equal to C, right? So minimum value will be 3. Otherwise, if A, B, C are unequal positive numbers, then the value of this expression will be greater than 3. Okay, now this is what the concept is. But whenever you have to find out the minimum maximum value of this sort of expression, so this is the property that is used. Okay, so to save time, what you can do is you can take A, B, C as equal, right? You can take all of them as 1. So you'll be getting 1 plus 1 plus 1. That's 3. That will be the minimum value, or we can say this expression will always be greater than 3. Okay, minimum value can be achieved when A is equal to B is equal to C, so that we are taking 1, 1, 1. So A by B plus B by C plus C by A is 3. That is the minimum value. Okay, so this concept can be used in many questions, right? This particular concept. This is the explanation and this is the shortcut. Okay, similarly we have this problem. Here the minimum value or the least value of this expression, that means the value of this expression will not be less than. Again, the shortcut is you just put up A, B, C as 1, so you'll be getting 3 into 3, 9. So minimum value of this expression will be 9. That is the shortcut. But you need to be conceptually clear. So what I do is we just go conceptually. So I multiply both of them, both these expressions. So that's 1 plus a by b plus a by c plus b by a plus 1 plus b by c plus c by a plus c by b plus 1. So 1, 1 and 1. So that is 3. Then a by b plus b by c plus c by a. Right? In the previous question we have already done this. A by b plus b by c plus c by a will be minimum 3. Okay. So 1 plus 1 plus 1, 3 we have already got. Then a by b plus b by c plus c by a is 3. Similarly, a by c, c by b and b by a. This will also be 3. Okay, so 3 plus 3 plus 3, it is 9. I hope you are getting it. Now see this question. If the sides of a right angle triangle form an AP, then sines of the acute angle is. Okay, now we have one set of Pythagorean triplet where the three sides are in AP, right? That is 3, 4 and 5. 3 is this, 4 is this and 5 is this, right? Now this is the angle of 90 degree and this is acute angle. I assume it to be X and this is angle Y, right? Now what we have to do? We have to find the sines of the acute angle. See 3, 4, 5 I am assuming, right? That is not true once for all. Maybe there are other sides which maintain arithmetic progression, or they are the sides of the right angle triangle, right? But this is the simplest one, so I am assuming this. 3 is the perpendicular, 4 is the base and 5 is the hypotenuse, right? And 3, 4, 5 are Pythagorean triplets. Okay, so what will be the value of sine x over here? Sine x is perpendicular by hypotenuse, so it is 3 by 5, right? So sine of one acute angle is 3 by 5, so we have 3 by 5 everywhere, and sine of other acute angle, that is sine y, is equal to, if this is the angle that we have to find, then this will be the perpendicular and this will be the hypotenuse, right? So perpendicular is 4 and hypotenuse is 5, right? So sines of the acute angle, sine x is 3 by 5 and sine y is 4 by 5. So your answer is 3 by 5 and 4 by 5. That's this. Okay. The length of the sides of a right angle triangle are in AP, then the ratio is simple. 3, 4, 5 we have just done one problem. 3, 4, 5 will always be true. Okay. Now see this question, going to be important one. If the ratio of sums to n terms of two APs is this, then the ratio of their 17th term. First of all, there are two arithmetic progressions. I assume the first term and the common difference of first is A1 and D1 and second one is A2 and D2, right? So sum of n terms. So first by second n terms, that is n by 2, 2A1 plus n minus 1 D1 by n by 2, 2A2 plus n minus 1 D2, and that is given to us as 5n plus 3 upon 3n plus 4. So we have to find out the ratio of 17th term. 17th term is A1 plus 16 D1 and here it is A2 plus 16 D2. Now you can see this is cancelled. Now there is no direct method to solve this problem. What you have to do is, see, you can see 2A1 over here, right? So if I multiply numerator and denominator by 2, then what I'll be getting? 2A1, 32D1, 2A2 and 32D2, right? Now 2a1 plus 32d1, and here 2a1 plus n minus 1 d1, and here 2a2 plus n minus 1 d2, right? So if I put, instead of n minus 1, if I put 32, I'll be getting this expression, right? This is the ratio of the 17th term of the first AP and the second AP, right? It was A1 plus 16D1. I multiplied the numerator and denominator by 2. So what I'm getting is 2A1 plus 32D1 and 2A2 plus 32D2. Now if I compare this to this, if I put n minus 1 as 32, right? So this is the same thing, 2A1 plus 32D1, 2A1 plus 32D1, and 2a2 plus 32 d2. That means if I put n minus 1 is equal to 32, I'll be getting this expression same as this expression, right? So n minus 1 is 32, that means n is equal to 33. So if I'm putting n is equal to 33 over here, and this expression is equal to this expression, that means if n is 33 over here, n will be 33 over here also, right? So here I put n is equal to 33. So 33 into 5, 168 in the numerator that we have just in this option. Okay, so that's pretty easy. If you know the logic how to solve this problem, you can solve it easily. Otherwise it's a tedious one. If you go this way, then only this problem can be solved. Okay, so an important concept over here. If the sum of an infinite GP and sum of the squares of its terms are both equal to 5, then the first term is, okay, I assume the GP to be AR square. Since it is an infinite GP, that means R is less than 1, right? And if the sum of an infinite GP and sum of squares of its terms, so this, the other GP, are both equal to 5. That means sum of this GP and sum of this GP, both of them are equal to 5. That means A upon 1 minus R is equal to A square upon 1 minus R square, right? And that is equal to 5. Now solve it. It is 1 minus R into 1 plus R. So 1 minus R and 1 minus R is cancelled. So precisely A upon 1 plus R is equal to 1. And we have already written that A upon 1 minus R is equal to 5. Right? So if I divide this expression by this expression, what I'll be getting is 1 plus R upon 1 minus R is equal to 5. Then you can apply the property of componendo divindo. 1 upon R is equal to 6 by 4, that is 3 by 2. That means R is equal to 2 by 3. And if you put the value of R over here, then you'll be able to get the value of A, either here or here. So A upon 1 minus 2 by 3 is 1 by 3 is equal to 5. So A is equal to 5 by 3. Okay. So here you can save time and space if you don't write this expression, right? And if you can save, in fact, this portion also. So this much is the paperwork required. Even it can be faster also. So just have some practice. Let's do the next one. Now we see this. The sum of two numbers is 2 1 by 6, that is 13 by 6 precisely, and even number of AMs, that is arithmetic means, are inserted between them. If the sum of these means exceeds their number by 1, then the number of means is, here it is A and here it is B, and A plus B is this, right? Now there are, I suppose, n means are there, so it's A plus D, A plus 2D till it is A plus N D, right? So 1 2 3 till n means are there. Okay, and here n is definitely even because even number of AMs are inserted. Now what? Total there are n plus 2 terms. Now if the sum of these means sum of a plus d to a plus nd, total there are n terms, so sum is n by 2, first term is a plus d, so for twice first term is 2a plus 2d, plus total number of terms are n, so here I'll put n minus 1 and common difference is d, right? So this is the sum of these means exceed their number is n, and that is equal to 1. Okay, and here you can see this is the first term in the entire sequence. If we talk about, this is first term, second term, third term, so b will be precisely n plus 2th term, so b is equal to a plus n plus 1 d, right, because it is n plus 2th term. So if you solve this, you'll be getting 2a plus here n minus nd minus d plus 2d, so precisely nd plus d, right, plus d, so it will be n plus 1 d. Now this is what 2a, instead of 2a I can write it as a plus n plus 1 d. Now this a plus n plus 1 d is actually b, right? So n by 2 a plus b minus n is equal to 1. Now a plus b we know that it is 13 by 6. So n by 2 into 13 by 6 minus n is equal to 1, right? So it is 13n minus 12n is equal to 12. So n is equal to 12. Okay? So total number of means are 12. I hope you are clear. Now this is an interesting question. The first term of an infinite GP is 1 and any term equal to the sum of all succeeding terms, the common ratio of the GP is. First of all, let's write that GP. First term is 1. I assume the common ratio to be r, then the second term will be r, r square, r cube, and so on, right? Now any term is equal to sum of all the succeeding term. That means the first term is equal to sum of all the succeeding terms. So what I do is I start from here, I add from this point to this term to this term. So again there are infinite terms, so the common ratio is r. So sum of this infinite GP will be what? First term by common ratio, right? So first term is r over here and the common ratio is also r, so r upon 1 minus r, and that is equal to 1. Sum of this entire sequence is this, and sum of all the succeeding terms is equal to the previous term, right? So this is actually 1. So r is equal to 1 minus r, that means r is equal to 1 by 2. Okay, very simple. I hope you are clear. Now this is going to be a very important problem. Here we'll be using the property arithmetic mean is greater than harmonic mean, right? And harmonic arithmetic mean is greater than harmonic mean, greater than equal to, in fact. So that's only one case where this harmonic mean is equal to arithmetic mean, when all the terms are same, right? So on this concept we'll be solving this problem. Apart from that, arithmetic mean, you know, that is sum of data by number of sum of observations by number of observation, that is arithmetic mean, right? Now what is harmonic mean of n positive numbers? Since all the numbers are positive, so what is the harmonic mean? I assume the harmonic mean to be h, then 1 upon h is equal to 1 upon n, 1 upon x1 plus 1 upon x2 plus 1 upon x3 till 1 upon x50. Precisely n is 50, right? So if there are 50 positive numbers, x1, x2 till x50, and h is the harmonic mean of these numbers, then 1 upon h is equal to 1 upon 50, 1 upon x1 plus x2 plus x3 till x50, right? Now what? As I told you, arithmetic mean is greater than harmonic mean. So if I take h, it will be equal to reciprocal of this, 1 upon 50 1 upon x1 till 1 upon x50, right? So precisely it is 50. Okay, so 50 upon 1 upon x1 till 1 upon x50, this is harmonic mean, right? Now harmonic mean is less than equal to arithmetic mean. So this data is less than equal to arithmetic mean. Arithmetic mean of all these numbers will be what? x1 plus x2 plus x till x50 by 50. x1 plus x2 till x50 by 50, right? So this total is already 50. Okay, so this is 50. So 50 by 50 is equal to 1. Okay, now if we go for cross multiplication, 1 upon x1 plus 1 upon x2 till 1 upon x50 is greater than equal to, because this term will go over here, so this is greater than equal to 50. Okay, once again, arithmetic mean of these 50 numbers will be greater than their harmonic mean. So harmonic mean of this 50 number will be 1 upon h. H is harmonic mean of these 50 numbers is equal to 1 upon 50, 1 upon x1 plus 1 upon x2 till 1 upon x50. So harmonic mean will be 1 upon h is this, so h will be just reciprocal of this. So what I did is 1 upon this entire term. So 50 will go up in the numerator, and in the denominator 1 upon x1 till 1 upon x50. And this is harmonic mean, and that should be less than their arithmetic mean. So it is less than equal to their arithmetic mean. So arithmetic mean of x1 x2 till x50 is x1 plus x2 plus x50 divided by 50. That is their arithmetic mean. Now x1 plus x2 till x50 is given to us as 50. So I put 50 over here. 50 and 50 is cancelled. So 50 upon 1 upon x1, this is less than equal to 1. So if you go for the cross multiplication, this data will go over here. So 1 upon x1 plus 1 upon x2 is till x50 will be greater than equal to 50, right? So this data is always greater than equal to 50. That means minimum value should be 50, and it cannot be less than 50. Okay, so what is the minimum value? That is 50. Okay, so this is the concept. But how do you solve in a quick manner? See, if x1, x2, all of them are 50, so maximum value of this will be, minimum value. So minimum value am is greater than equal to hm. So both of them are equal when all the data are same. So what we'll do, I put x1, x2, x3 till x50, all of them as 1. So I'll be getting the sum as 50, right? If x1, x2, everything is 1, then this sum will be equal to 50. All of them are equal, and all of them are equal to 1. Okay, so I'll be getting the sum as 50. So if I put x1, x2, x3 as 1 over here, so I'll be getting 1 upon 1, 1 upon 1, 1 upon 1 till 50. So I'll be getting 50. So that is the shortcut technique. But before that, you must be knowing this concept. In examination, you don't have to show this working. It's just for your conceptual clarity only. Otherwise, you can directly put the value of all of them as 1. You'll be able to get this answer instantly. No paperwork is required at all. Okay. Now let's try this problem. The sum of products of every pair of first and natural number. It seems to be lengthy. What you have to do is actually the natural numbers 1, 2, 3 till n. If you make every combination pair, every possible pair, that's 2 into 3, 2 into n, 3 into 4, 4 into 5 something, right? Every possible combination. So precisely be getting NC2 combinations. So these many combinations you have to find out, and you have to find out their sum. So problem is lengthy. How you can find this out? That is, I assume NC2 to be P, right? A variable I assign. So it is 1 plus 2 plus 3 till n whole square is equal to 1 square plus 2 square till n square is equal to 2 times 1 into 2 plus 2 into 3. This NC2 combinations, right? So all these combination added, I assume them to be P. So precisely this is P, right? So now this is what the sum of first n natural number. So that is n plus 1 by 2 whole square. This is sum of squares of first n natural numbers. So formula is n plus 1 to n plus 1 by 6, and this is, I'm sorry, this is plus 2p, right? So p we have to find out. Now you have to simplify this expression, and then you'll be able to get the value of p. That is one among the options. But obviously this calculation, or this, to solve this expression, it will be really time consuming, right? So what we can do is we just take the comfortable values of n and try to simplify the problem. Okay, let's try that. So what you can do is you assume n is equal to 3, right? That means the sum of products of first 3 natural numbers, right? Pair of first 3 natural numbers. So that is 1, 2, 3. So all the possible combinations are 1 into 2, 2 into 3, and 3 into 1. So we have to find their sum. Okay, so 3 plus 6, 9, and 2, 11, right? That means when n is equal to 3, sum of every pair of natural number is 11. That means if I put n is equal to 3 in option A, B, or C, wherever I'll get 11, that will be the correct choice, right? So what I do is I put n is equal to 3 and check the options one by one. So n is equal to 3, and this is 4, and this is 3 3s are 9, 3s are 27, minus 5, 22 by 24. Okay, so that's 11. So if I put n is equal to 3 over here in the option A, I'm getting 11. So this is the correct choice, right? Now all the expressions, like whether C or B, these are different from this, because it is n plus 1 over here, it's n minus 1 over here. So you won't be getting any the same answer in any other case. So you don't have to go for much verification now. Okay, and this option A is the correct choice. I hope you are getting, and this much paperwork is required to solve, and the problem can be solved in less than 40 seconds, right? If you go this way. Now in a GP, the product of first 4 term is 4, and the second term is reciprocal of the fourth term, the sum of infinite terms of GP. I assume the GP to be AR square, AR cube, and so on. The product of first 4 term is 4. So product is actually A raised to 4 and R raised to 3, 4, 5, 6, right? And that is 4. Second term is reciprocal of the fourth term. So AR is equal to 1 upon AR cube, right? That means AR into AR cube is equal to 1. Or I can say A square R raised to 4 is equal to 1. So if you square both the side, what you'll be getting? A raised to 4, R raised to 8 is equal to 1, right? So, and if we divide this expression by this expression, what we will be getting is R, A4 will be cancelled, R square will be 1 by 4. So R is equal to plus minus half. Okay. Now sum of infinite terms of GP. So that is A upon 1 minus R. So for that we need to know the value of A. Now R is equal to plus minus half, so R4 will be 1 upon 16, and that is 1. So A square is 16, that means A is equal to plus minus 4. Okay, now friends, that's a different type of question actually. We have 2 values of R and we have 2 values of A, right? So if we choose the combinations, we'll be getting all these values, all these options as answer. Say suppose A upon 1 minus R. If I take A as 4 and R as half, then it is 8, right? If I take A as minus 4, then I'll be getting minus 8. If I take R as minus half, then I'll be getting 8 by 3. If I take R as minus half and A as minus 4, then I'll be getting 8 by 3. In other case, I'll be getting minus 8 by 3. So precisely all of them are correct answers, right? Now see, if A and B be two positive unequal numbers, then this expression represents their arithmetic mean if n is equal to 0, their geometric mean if n is equal to half, their harmonic mean if n is equal to -1. So let's try this. Arithmetic mean if n is equal to 0. So I just put n is equal to 0, so I'll be getting is a plus b by a raised to 0 plus b raised to 0, that means 2. So if n is equal to 0, it is a plus b by 2. So definitely a plus b by 2 is the arithmetic mean of a and b. So that's really correct, right? Now let's check the remaining one. If n is equal to half, we cannot get the geometric mean because it will be a lengthy, tedious term. Okay, and the geometric mean of a and b is actually a root ab, right? Similarly, if their HM is if n is equal to -1. So if n is equal to -1, it will be a raised to 0 plus b raised to 0. So that is 2 upon 1 upon a plus 1 upon b. So it is 2ab upon a plus b. Yes. So their harmonic mean if n is equal to -1. So that's correct. So in this case, two options are correct. Okay, A and C. Maybe your fourth option, instead of none of these, suppose it is A and C, right? So this will be the correct choice. Okay, here I'm just explaining you how to calculate, how to do the problem. That really doesn't matter how many options are correct, right? If two options are correct, you have to just understand this thing. In your examination, maybe there is only one option correct, but you should be knowing the procedure, right? Now this problem, here 1 upon 1 square plus 1 upon 2 square 3 up to infinity is given to us as pi square by 6. Now we have to find out the value of 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square till infinity, right? So this is actually, we can see odd terms, right? 1, 3, 5 and so on. Here all the terms are included, right? So suppose this is I write it 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, that's one group, plus 1 upon 2 square plus 1 upon 4 square plus 1 upon 6 square, that's the second group. Now value of this group we have to find out. Now this entire thing is actually pi square by 6, right? And we have to find out the value of this. Now this is, suppose I assume to be x. So x plus, here if I take 1 upon 2 square as common, what I'll be getting is 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square, and that is actually pi square by 6. So this thing is again pi square by 6. So pi square by 6 by 4. So that is actually pi square by 24. Now we have to find out the value of x. So x is equal to pi square by 6 minus pi square by 24. So that is 4 pi square minus pi square, that is 3 pi square by 24, that means pi square by 8. Okay, I hope that's clear to you. So friends, I hope the problems based on AP, GP and HP are clear with you now, clear to you. Just have some good practice, and we'll see you in the next session once again. Bye bye.